Just a video walking you through this activity data collections and transformations. All right, so the assignment here, there's a bunch of aspects to it. This is for your daily data. So the spreadsheet that you've been recording your daily data, that's the one that we're going to use for this assignment. The instructions that I'm about to give you assume that you've been collecting the data appropriately. So what you see here in the left half of my screen is what appropriately collected data should look like. Right? So the date in the first column, your first variable's information in the second variable's information in the third column. Right? I use appropriate labeling here so that I don't have to put anything other than the number in each cell. All right, so because what I'll see is a lot of folks writing things like, I'll say degrees. They'll write that, and that'll mess up all the calculations. So we put the units in the title and just the numerical value in the column. All right, so the first thing I'm going to have you do is create a scatter plot. I said somewhere over by G1, in this general neck of the woods. You're going to create a scatter plot for all of your data. Now this is for a full year course, so I have around 180 plus values. You should have, by the time you're ready to put together your final project based off this data, you should have about 40 to 50 data points. All right. But regardless, you're going to highlight, go to Insert, Chart. We want it to be a scatter chart. I overshot it. There it is. We want it to be appropriately labeled. So let me have a look. Low temperature. So I don't think I need these titles. The axes seem to do the job for me. So I did high temperature versus low, and that is consistent with what we have. And you can see here it's very densely populated scatter plot. All right, I'll resize it and get it in over there. All right, so now I have an idea of what the general trend of the data is, but I want to dig deeper. So we're going to create 4 new tabs. So plus sign, call the first one linear. Another one, so linear, exponential, quadratic, and logarithmic. Rename, so you gotta read it. It's a little tedious, but. And then logarithmic. Now, if you want, instead of reinventing the wheel, you can go into one of the older assignments. And in fact, that's kind of been the point. We do all these individual assignments so that you have something that's already made that you can just manipulate row, column references to. So in this case, the one that makes the most sense would be the, where are you? Activity transformations, right? So when you click on that, it'll bring you to your work. I would go into your solution. So I have my my answer key here, so I'll just pull off of that. So we did a linear transformation here. So what I can actually do is just copy everything that's in that little area there and bring it over, and then we'll just move some stuff around. All right. So it doesn't bring the graphs along. You'll see here that it's referencing the wrong stuff, right? So there's some work that needs to be done, but what I'll do is I'll take this, put it over here. I'll take my residual plot stuff and put it over in this neighborhood. And we'll update all those references in a minute. It's not age, it's not income, it's high temperatures and low temperatures, all right? So what I'll do, let me expand this a little bit, is I'll take note of the reference here. It's in B1 and C1, all right? And you see here when I hover over this, that little comment that I put in, I put a comment in related to where I got the information from. And that's something that you should really be doing, because if you go through these data points and you see something that kind of stands out, maybe as an outlier, you could make reference to that by putting it in a comment. So, for example, on 11.7, I see a really significantly, or in my opinion, high temperature. So I'll make a little note. I'll say possible outlier. You know, I put a little note there just to kind of remind myself down the line, right? But anyway, for my linear case, I want to pull everything from this spreadsheet and put it into A2 here. So I'll do equals, then I'll kick over here, select that, hit enter, and then drag it on down the line. Now again, I have way more data points than you might have, but I'm gonna include everything, all right? So same idea here, equals, we want C1, lock it in, drag it down. And you know what, now that I'm kind of doing this, one thing that you might want to consider is maybe holding off on making the other 3 tabs, because if you do that, then you can duplicate this and it'll have this stuff along with it. And it's just a thought, right? Now for my y-intercept, it's definitely way more than B4 to B11. My data goes from, actually something went a little wonky here. Undo. Yeah, now it's good. I don't know, I must have clicked on something weird. So it's going from B3 all the way down to B100 something or other. So I'm gonna uncap my B on, I believe, Excel. It sometimes gets mad if you try to do that. So just put in whatever the reference is for your last value. So I think it's 185 or something like that. All right, and who's to say, maybe it'll get mad at me for doing it in Google Sheets, but let's see. Okay, it looks all right. All right, but if I did, I think it was 185. I gotta change them both. Oops, I hit the wrong thing, lordy. All right, you see, it gives the same number, so I'm feeling pretty good about that. All right, so you can cap it, click on the right thing, or just leave it uncapped in Google Sheets. I'm pretty sure you have to cap it at whatever the last row is in Excel. So I'm gonna do the same thing here. I got these references, might as well make use of it, so I'll just do a quick copy and paste. Lock it in, so I have my slope, my R squared value. So again, correlation. So that's an R value, and for images won't come over either. So maybe make a note here, like R squared, because that R squared that I have in the other spreadsheet, I pasted an image into the cell. So this correlation value is just the R. I want it squared, so raised to a power of 2. Now I'm looking at an R squared value it's in the neighborhood of 1, so you might make the case that this is a good fit. I want residual values. So what I'm gonna do here is get rid of this. Well, not really get rid of it, I'm just gonna pop it in over here. Oops, hit the wrong thing. Let me just, there we go. All right, so we're gonna update these references, same deal. Now I can do this off of whatever I have here, or I can refer back to the original spreadsheet. I think it's a little easier to just do it based off what we have here. So equals A2, and then drag it on down the line. Pretty sure it was 185, but I will double check right now. Yep. Now for the residual values. So that's the difference between the observed and the expected. All right, so I have the observed values here. I don't have the expected or predicted values. So what I need to do is use my equation here, update it based off of the references. So the first reference should be my y-intercept, which is in F1. So F1. My slope is in F2, so F2, and A3 is the observed value, so that's good. All right. So based off the high temperature, can we compute the low temperature or estimate or predict? That's really what the question is, right? So we figure out what our prediction model would tell us if the high temperature is 77, what the low temperature is going to be, right? So that's what these predicted values are giving us. You can leave the highlight on or not, it doesn't make a difference. Since the length of the lists are going to vary from person to person, I don't really feel the need to like mandate something like that, but yeah, it's something to keep in mind. Somehow I lost the power of 2 here. I must have hit undo at some point. I'm just going to put that back in. All right. So these are my predicted values, and you can see in some cases they're pretty close. Some cases not so much. All right. If this were an R-squared value of 1, then these would be pretty much identical. All right. So my residual values, the calculations are happening, which is nice. B3 minus C3. It's not happening for all the values. So let me just drag it on down the line. So those are my residuals. Let me make a residual plot. Again, scatter plot of this residual information. Insert chart, high temperature versus residuals. Feel good about that. Let me get rid of this. Let me close this down. Oh, I do not see a pattern at all. This is just randomly or seemingly randomly plotted points. So I am going to select no. So this model is likely appropriate. But we don't just stop there, because this is a pretty good R-squared value, but it's not great. And if I look at the original trend of the data, yeah, it looks like it's probably linear, but I have nothing to compare it to yet. So that's why we're going to pretty much do this again, but we're going to move on to the exponential model. All right. So that's what I'll do in the next video.